In the previous video we looked at how the trapezium rule comes about. In this video I'm going to show you how it works. And we're going to start off by looking at the integral of x plus 5 over x plus 3 evaluated between 0 and 4. And we're going to be dividing this up into 4 strips. Now, first of all, this is the integral of a function that we currently do not know how to integrate. Okay, so that is why we have been given it here, and that's why we are going to be able to estimate it. When you learn a technique of integration known as integration by substitution, you would be able to integrate this analytically and so get an exact answer. But in this case we're going to be looking at an approximation. So the first thing is to determine the width of the strip, and that is h. Now h is given by the difference between the two coordinates on the x-axis, between the 4 and the 0, divided by how many strips we want. And the number of strips is 4. So that is just 1. So we have strip lengths of width 1. Now it is good practice at this point to then build up a table of results. Now we have ordinates from 0 to 4. So we begin at 0. So these are going to be my x's that I'm substituting in. So 0 and width 1, so 1, 2, 3, 4. Okay? So notice how we've got 1, 2, 3, 4, 5 ordinates. So 4 strips, 5 ordinates. There is always one less strip than there are ordinates. Or there's always one more ordinate than strips, if you want to remember it that way around. So if the question had given us 5 ordinates, rather than telling us 4 strips, we would still know, right, 5 take away 1 is 4 strips. And then we've got x plus 5 over x plus 3. Then we're substituting each of these values into this function. Now, I would probably keep these as exact answers, if you can. So substituting in 0, we get 5 over 3, so I'm just going to write it as 5/3, rather than turning it into a decimal. Then I've got 1, so I've got 6 over 4, which is 3/2, but I'm going to keep it as 6 over 4 for the moment, okay? Just so it's easy to look back and check if anything's gone wrong. Then I'm putting in 2, so I'm going to get 7 over 5. Putting in 3, I'm going to get 8 over 6. And then putting in 4, I'm going to have 9 over 7. Okay, so these are my y ordinates, which I can then substitute into the formula. So this area is approximately equal to 1/2 times h times the first plus the last plus 2 times the rest. So this is 1/2 times h, which is 1, times the first, which is the 5/3, plus the last, which is the 9/7, plus 2 times the sum of the rest. So I'll pop that into the calculator, and if you're not confident with your calculator skills, it's best to take it out one step at a time. So 100, that's 127 over 30, timesing that by 2 is 127 over 15. Add those two fractions, plus 9 over 7 plus 5 over 3. That gives me 1199 over 105, and then I'm dividing it by 2, or multiplying by 1/2. So my answer is 1199 over 210, which is 5.71 to 3 significant figures. Okay, so that is an estimate of this integral. Now, one thing that you might be asked to do is to determine whether this is an overestimate or an underestimate. And really this is a technique of how well you can spot what the graph is doing. Now, if the curve is going downwards and I draw a trapezium, then the top of the trapezium would go over the top of the curve. And so the area of the trapezium would give me an overestimate. If the curve was looking like this, and I draw a trapezium, then the bar, not very well done, but you can see that the top of the trapezium would be going underneath the curve. And so that would be an underestimate. And so we need to determine whether the curve looks like this or like this between 0 and 4. Now, how that can be done is by looking at the y-coordinates. So the y-coordinates, as you look at them, you could plug them into a calculator. 5/3, well, 5/3 is 1.6 recurring, or 1.67 for 2 decimal places, and 9/7 is 1.29. And so we can see that the curve is decreasing between 0 and 4. I mean, that's not a proof that it's decreasing, but it's telling us that it has decreased, and they're not going to give you a curve that's all over the place, and so it will be a constant downward trend. And so our area that we get will be an overestimate of the actual area. Okay, so because that's going from 1.67 to 1.29, so it's decreasing, we must have an overestimate. Okay? And that is how we can use the trapezium rule.